Hello students, hope you all are well and good, enjoying your life along with your studies. So today we will be studying a new chapter of class 11 physics, which is Newton's law of motion. Before going deep dive into this chapter, let's first understand what exactly the topic means. If we take a look at the first word of this topic, which is Newton. So Newton was a great scientist. Let me write it over here. Newton was a great scientist who was born in 1642 and lived till 1727. And all we know that the famous story that someday Newton was sitting under a tree of an apple and an apple suddenly came down from the tree, and Newton started thinking why this apple doesn't went upward instead of coming down. So after studying this phenomena, Newton has given us the famous law of gravitation. According to this law, what exactly this law means that two masses of m1 and m2 placed with a distance between them r will exert an attractive force towards each other, which is given by m1 m2 upon r square. Let me repeat this. So two objects of mass m1 and m2, let's suppose the distance between them is r, then these both objects will exert an attractive force of F towards each other, and this attractive force is given by G m1 m2 upon r square, right? Where G is gravitational constant, where G is gravitational constant. Okay, now let's understand the second word, which is law. So before understanding law, let's first understand what exactly the rule means. So we all play cricket in our colony or somewhere in ground, and we make certain rules that if someone hits the ball from the bat and that ball goes directly into the player's hand, then that player will be out. Or we make some certain rules that can be further changed, like if the batsman hits the ball and it crosses the fence of some, or it enters someone's home, then that player will be out, right? So rules are such things which can be changed, whereas laws are such things which are universal true and are never be changed. Say for example, like as I have mentioned that the gravitational force is given by m1 m2 upon r square, and because this is a law, so this is true on Jupiter, on Sun, on Mars, on Earth, everywhere this law will be true and will be applied, right? So laws are such things which are universally true, which are universal true, and multiple times tested and verified. And we have multiple times tested and verified. Now let's understand what the next word means. So next word is motion, right? So what exactly this motion means? So if there is change in position of any object, like if an object is changing or going from one place to another place in a certain interval of time, then we say that object was in motion, or that object is in motion, right? So if I write over here, then motion is change in position position with respect to time. Hope this topic is clear to you all. Now let's go deeper into this chapter. So to understand motion, the first person came into picture was Aristotle in around 384 BC. And whatever was his thought, today we study his thought as Aristotle fallacy. So let me write over here. To understand motion, the first person came into picture was Aristotle in around 384 BC. And today we study his thought as Aristotle fallacy. Now let's understand what exactly this Aristotle fallacy is. So according to Aristotle, if there is any object of mass m moving with a constant velocity v, then this constant velocity will must be driven by some external force. Or what I mean, or what Aristotle exactly mean was, if any object is moving with a constant velocity v, then the motion of that object must be driven by some external force. That some external force must be applied to that object. Then only an object can move with some constant velocity or with some velocity, right? This was the thought of Aristotle. Let's understand in a better way. If I consider a car toy, and suppose there is a string, and suppose a small kid is there, then this car toy will get a velocity v only if when this kid will pull this string towards, when he will apply an external force, right? Now suppose there is another car toy and this is a string. Now after the kid exerted an external force F and pulled the car to give it a velocity v, and now if we cut the string at some instant, then the car toy will come at rest, right? So what exactly it means, that the kid has applied some external force and due to which the object comes into motion, right? And once we cut the string, so this results into that we have cut down that force, and after removing that force, then the object come at rest. So let me first write what was the statement given by Aristotle, or what is the statement of Aristotle fallacy. Let me write down the statement. So statement was that an external is required to keep any object in motion. Hope this statement will be clear to you all. So what this exactly means, that an external force is required to keep an object is in motion, right? Now a question came into scientist mind, that if there is an object and an F force is applied, an external force is applied on that object to move, and if at any instant, if we cut down of, or if we remove this force, then according to Aristotle, the external force is required to keep any object is motion. And then we can say that if we remove that force, then object should come at rest at that instant only, right? But what happened, that after cutting this string, what scientists observed is that this object moved for a while, instead of instead of that this object moved for a while instead of stopping suddenly. So after like acknowledging this phenomena, scientists like said that whatever was the Aristotle thought, that was not accurate. So the statement given by Aristotle, that an external force is required to keep any object in motion, that was not accurate. Then we might can think, so what is the correct statement, right? So many of the scientists started studying the phenomena of motion, and some of them were Leonardo da Vinci, Coulomb, and after the mutual understanding, they provided us a very good concept which is known as concept of friction. So let me write over here, concept of friction. So what exactly they mention, that if an object is moving with a constant velocity v, then an external force is required not to move that object, but instead to overcome a force which is known as friction force, that exists between the contact surface, that is ground, and that object. Let's suppose there is an object of mass m at rest on a rough surface, and an external force is applied F. Then we all know that the friction force will try to oppose the relative motion, or we can say the friction force will try to oppose the object moving forward, and the friction force will be applied in backward direction. We write friction force as Fs. 300 times if we zoom this, what exactly happens, that because the surfaces are rough, so they get interlocked with each other, and because the above body, or we can say the above surface, we are trying to move it in forward direction, then what happens exactly, the the below surface hits the above surface, hit, hit, and hits the above surfaces. This hitting force is nothing but we called it as contact forces. Contact forces. So exactly what happened that suppose this is R1, this is R2. These are the contact forces, right? R3, okay, and so on. If we look closely, then these are the contact forces, right? What exactly happens is that the vertical component of this contact force is nothing but normal, nothing but normal N1, N2, N3, and N4, N1, N2, N3, and N4. And the horizontal component of this contact force is nothing but friction force F1, F2, and F3, and so on. Now the resultant of this horizontal component of of contact force is the nothing but friction force. Okay, so we can say that the resultant or net of this contact force is nothing but net contact force. Net contact force. This is R net. The horizontal component of this R net is nothing but normal in upward direction, and horizontal component of this R net is nothing but friction force. So if I repeat, then two surfaces when are in contact, and if we are trying to move this capital mass M forward, the above surfaces we are trying to move forward, and because of this, the object, because the surfaces are rough, so they are get interlocked with each other, and the lower surface tries to hit the above surface, and because of this contact forces get developed, and the net of this contact force we called is at net contact force, and the horizontal component of this is nothing but friction, and the vertical component is the normal reaction. Hope you all understood the concept of friction very well. We will be understanding this concept of friction in more detail in upcoming chapter of friction. So the exact correct statement was, let me write over here, the correct statement was that for any object or body, for any object or body to be in motion, to be in motion, a net external force is required to overcome, to overcome some opposing forces, opposing forces such as friction, which exist in solids, mainly in solids, and viscous force that exist in liquid or gas. So the correct statement is that if any object is in motion and an external force is required to overcome some opposing forces, which is nothing but friction. So if we want to feel what exactly friction is, let's bring our palm together. Okay, and now if we want to pull this palm upwards, then if we apply a very little force upward, then it might be possible that this palm will not go upward, right? Why? Because if we look at our palm, then it might looks us that our palm is very plain and very smooth, but this is not the case. These surfaces at a microscopic level, the surfaces of our palm is very rough, and if two rough surfaces come in contact with each other, then the surfaces get interlocked with each other, and due to which a type of force exists between the contact surfaces, which is called as friction, that tries to oppose the relative motion of one surface with respect to other. Then that friction force will oppose that this palm will not go upward, right? Now if we understand what exactly the viscous force is, suppose there is a honey, right, and there is a water. If we put honey and water on a two different sliding surfaces, we might can observe flow rate of honey is much slower than the flow rate of water. Why? Because honey has much more viscous force than with respect to water. Then we can say honey have much more viscous force with respect to water, right? Hope you all have understood the concept of friction and what Aristotle fallacy was and what was the correct statement. Now let's move forward and understand what is law of inertia. Let me write it over here. Law of law of inertia. Law of inertia is also known as law of inertia, means resistance to change. Law of resistance to change. What is exactly this law is that if any object is in rest, then it will resist it will resist to come in motion. If any object is in rest, then it will resist to come in motion. And if we want to bring that object which is in rest in motion, then we must need to apply an external force. Okay. Now, similarly, if any object is in motion, moving with a constant velocity, then it will resist to come at rest. In order to bring an object which is moving with a constant velocity at rest, a net external force must be applied to bring that object at rest. Okay. So now let's understand what exactly inertia is. So inertia is the property of any object which tries to resist its change in state, and it is directly proportional to mass. Let me write first over here. It is property of an object to resist change in state and directly proportional to and directly proportional to mass. Let's understand how it is directly proportional to mass. Let's try to feel what exactly the inertia is. Suppose, uh, suppose there is a ball coming towards towards you with a constant velocity v, right? And you are standing in front of that coming ball. Suppose the ball is a rubber ball or a plastic ball and having a very less mass, right? Okay, so that ball hits you, and I don't think you will be getting hurted, right? Okay, now let's change the situation. Suppose you are a Superman, and suppose there is an asteroid in the space and it is coming towards you with a constant velocity v. Okay, and if you are standing in front of an asteroid, then you are definitely going to be destroyed, right? Hope these two situations might help you to understand how inertia actually directly proportional to the mass. So exactly what you are trying to do, that in the first situation, the rubber ball or plastic, you are trying to oppose or resist the motion of that moving ball, right? But because the mass of the ball was very less, so it will not hurt you. But if we replace that ball with an asteroid of very heavy mass, and if you are standing in front of that asteroid, then you will be destroyed, right? So why if this is happening? Because more will be the mass, more will be the resistance to change, and to overcome that resistance, a huge amount of force is also required. So that's why inertia is something that is directly proportional to mass, and it is the property of any object which tries to resist its change in state. For example, train is having much more inertia than a bus, and sun is having much bigger inertia than train or bus. Okay.